Okay, so we're going to be looking at algebraic numbers for our last hour this week. And so we're looking at things like this, 4x. And we mentioned briefly that numbers always have two parts. And let's see that it sticks out here as being the same. The 4 is our count, telling us how many we have. We have 4 of something. Just like having 4 inches, 4 milligrams, 4 sevenths for a fraction. And the x is our name. Just like having inches or milligrams or sevenths or whatever. So when we deal with our operations with these algebraic numbers, it'll be the exact same thing as our operations with whole numbers, fractions, decimals, whatever. When we add or subtract, we must have the same name. So we might have 4x plus 9x. Those are the same name. They're both x, so we can add them. 4 and 9 make 13. We combine the counts, and we keep the same name of x. If we were subtracting 13x minus 7x, again, we have the same name. They're both x. We can subtract. 13 minus 7 makes 6. We combine the counts, and we keep the same name of x. We do have to be careful. We run into something like 5x plus 2y. What do we get there? Perfect. Trick question. We get 5x plus 2y. They have different names. They cannot be combined with addition or subtraction. And one that's always a little bit trickier might be this one. 5xy plus 3y. Well, people look at that and say, well, we've got a y in both of them. But this is an xy and this is just a y. Very similar to having foot-pounds and feet. You can't add them because those are different units or different labels. When we multiply or divide, 3x times 4x, when we multiply or divide, we're going to combine the counts. 3 times 4 is 12, but we're also going to combine the names. X times x makes x squared. Very good. Because of that difference, excuse me, if we have 5x times 2y, to multiply or divide, we do not have to have the same name. So we can go ahead and combine these. Perfect. We combine the counts. 5 times 2 is 10. And we combine the names. X times y is xy. Only when we multiply and divide, yes. When we divide, we can come into some interesting consequences here. Like here for dividing, that's just a short way of writing division, by the way, using it in fraction form. 12x divided by 3, we can divide the counts. 12 divided by 3 is 4. And then we are also going to divide the names, but here we've got an x. The name on the 3 here is 1s. If there's nothing written there, a number by itself is always the 1s. Well, x divided by 1, anything divided by 1 is itself. So that just stays x. We might have 20x divided by 4x. Here again, we're going to combine the counts. What's 20 divided by 4? 5. Then we're also going to combine the names. X divided by x cancels out. So our answer there is just going to be 5. And then, of course, the final case we could have might look like this. 18x squared divided by 3x. So 18 divided by 3, 6. X squared divided by x is just x. Okay. we're going to do a whole lot, if this were a more formal algebra course, we would do a lot more with combining those algebraic numbers. Those of you that go on to a 4-year degree, you will have to take a formal algebra course. So you will deal a lot more with those variables. For our purposes, we just need to be able to do the basics for now so that we can deal with stuff like this. That, of course, is called an equation. The key to it, of course, is this symbol, the equal sign. The question that seems very simple but is actually kind of tough to put in words is, what does that equal sign mean? The same as is a good one. Yeah, it's really hard a lot of times to try to define it without using the word equals. The equal sign means what is on one side has exactly the same value as what's on the other side. As we talked about just, was it 2 weeks ago? Last week we talked about it a little bit, didn't we? Solving equations. Trying to remember how far we got into it. We didn't touch on it much last week? Okay. Making sure. So we can think of this as a balanced scale, is what's on one side of the symbol exactly balances what's on the other side of our equal sign. They have exactly the same weight or value. Every equation starts out as just a variable equals a number, and they're built up from there. How do you build an equation? Well, you can use any of our basic operations. You can use addition, subtraction, multiplication, division, even our other operations, powers and roots, trig functions, and all that good stuff. So let's do a relatively simple one here. Let's add 3. So we're going to build onto this equation by adding 3. So this is now x plus 3. However, this scale is going to tip unless we do what? Do the same thing to the other side. We add 3 to the other side. So 7 plus 3 is 10. We have to do the exact same thing to both sides of our equation to keep that scale balanced. So the equation stays balanced. So we have built a slightly more complex equation here. Most of the time, however, we're not asked to build equations. The thing we're asked to do is solve an equation. To solve an equation, what we're being asked to do is to take it back apart and get it back to this form where a variable equals a number or a number equals a variable. So this equation was built by adding 3. How would we take it apart? We would subtract 3, removes that piece from it, leaving us with x. Now again, because we have to keep it balanced, we have to do the exact same thing to the other side. Subtracting 3 from 10 leaves us with 7. So x equals 7. We've solved that equation. On that equation, we built it, so we knew how it was built, so we knew exactly how to take it apart. Most of the time, you're just going to be given the equation, and you have to figure out how it was built. To do that, let's take a look at something like this. Y minus 7 equals 8. To figure out how that equation was built, you find the equal sign right there. Then you identify which side of the equal sign has the variable on it. So that's going to be the left side. Looking at that side now, you have to ask what's keeping the variable from being alone there. And in this case, it's the 7. And what operation is used to attach the 7 to our variable? Subtraction. So that's telling us is this equation was built, what was done to y to build this equation was subtracting 7. So to take it apart, we would add 7. Removes that minus 7, leaves us with y. We have to make sure we do the exact same thing to both sides. We add 7 to the 8, makes 15. So y equals 15. If you want to be absolutely sure of your answer, you can go back to the original equation and put in that 15 for y. Y minus 7 equals 8. That would become 15 minus 7 equals 8. This 15 minus 7 equals 8. So we get the same value on both sides of the equation. Now, they're not all going to be that simple. They're going to get more complicated. You won't have too much time in class with me before you figure out I always make it worse. It's kind of my job. So, what's that? Oh, there you go. 3x minus 5 equals 16. So here we find our equal sign right here. We identify where the variable is on the left side. And this time there are two things that are keeping our variable from being by itself. There's the 3 and the 5. The 3 has been attached to the variable with what operation? Multiplication. When it's written right next to the variable like that, it's implied to be multiplication. The 5 was subtracted. So what's been done to our variable to build this equation? If you picture that the x is a number there, our order of operations would tell us which one happens first. Multiplying. So this was multiplied, the variable was multiplied by 3, and then 5 was subtracted from it. Now, if you put something together, whether you're putting together a piece of furniture, maybe a toy for one of your kids, put anything together, you've just finished up, you've just put on that last piece. If you have to take it apart again, what's going to be the first piece you take off? The last piece you put on. The last piece put on here was subtracting 5, so that's going to be the first piece we have to take off. So we are going to add 5. So that removes that minus 5, it's gone. We have 3x left there, equals 21. You got it. Now we go back and take off the multiplying by 3 by dividing by 3. So we divide by 3, that 3 is gone. We have to make sure we divide the other side by 3 as well. 21 divided by 3 is 7. So x equals 7. We've taken that equation apart and got it down to that basic form of the variable equals a number. Let's double check this. So if x equals 7, we should be able to put 7 in here and get the same value on both sides. So 3x becomes 3 times 7 minus 5. Now there's nothing to do to the 16. 3 times 7 is 21. Minus 5 is 16. So we do get the same value on each side of that equation. Any questions so far? I'm going to have you try to solve that one in your notes quick. See if you what you come up with. We'll talk about it in just a minute. So what's the first thing we have to do to take this apart? Subtract 2. So 28 equals 7z. And then divide by 7. So 4 equals z. And of course, we could go back and put in the 4 where the z is. It'd be 7 times 4 plus 2. And you would combine that to make sure it comes out to be 30. And it does. Good question. Some people don't like seeing it like this with the variable on the right side. These two things are equal. So it doesn't matter which one comes first. So yes, you are exactly right. You can just switch it so that the 7z plus 2 is first and then the 30 is on the other side. Because if these two things balance on a scale, well, if you switch the sides, the scale still balances. The key is just make sure that all the pieces stay together. That you don't leave one piece behind or anything like that. So if we look at this one here, We find our equal sign and we look for our variable. We notice the x appears twice. Now, if we're thinking of that balanced scale, the x does appear on the same side both times. So in this case, if I were to just take them and push them together and make one big pile, would it change how this scale balances? No. So 3x and 2x make 5x. We still have the minus 2 there. So the left side of that scale, that equation, becomes 5x minus 2, and that's still going to equal 38. Yeah, so now it's down to that form we're used to. And you're right, we're going to add 2. So the minus 2 is gone. 5x equals 40. And then what? Divide by 5 to get x equals 8. And of course, as always, you could go back and put 8 in here for x in each spot and double check it. See, 24. 2 times 8 is 16. 24 minus 2 is 22, plus the 16 is 38. So yes, you get the same value on both sides. I was thinking you get an A for enthusiasm. What you guys gotta understand is I think in cartoons. So when you guys say stuff, there are times where like dozens of cartoons are flipping through my brain. And no, I shouldn't. They're very amusing to me, but I don't think other people would understand them because I'm kind of strange. I can admit that. Well, I do math every day of my life. I have to be a little bit weird, right? You're not, don't have to agree quite so enthusiastically with that one. I'm just saying. It is okay to, patronize the teacher a little bit. Okay, something like this. I'm going to have you guys try that in your notes and see how you come out. Something's a little off there. So you are going to combine the 7, and you'll notice that is a negative 4. So that's going to make 3x. That is still plus 9, however. If you got 14, you probably accidentally changed it to a minus 9. So now we have to subtract the 9. So 3x equals 24. And divide by 3. Yeah, you added the 9 instead of subtracting the 9 as well. Okay. That one is slightly different than this one here. Remember, we find the equal sign and we look for the variable, but here the x appears twice again. Unfortunately, it's once on each side. We can't just push it together in a big pile like we did over here. We have to get rid of one of them. Mathematically, how we get rid of something is we subtract it. Or if it's negative, we would add it. So I have to get rid of 1. Usually I would go after the smallest one I would get rid of. So the 3x, we're going to subtract it to get rid of it. That leaves us with just 15 over on that side. We do have to take 3x away from the other side as well. We can only take it from the 5x because they have to have the same name. That's perfect. So we're left with 2x plus 7 equals 15. Now this is in that form we know how to solve. What do? Subtract 7 to give us 2x equals 8. Divide by 2 to get x equals 4. Perfect. Yep. Okay. Yep. Just like with fractions, the operation always operates on the number that comes after it. Same thing here. These operations go with the number comes after it. So that's a plus. That's saying that's a positive 9. That's a minus. That's saying that's a negative 4x. So that's a very good question. I should have pointed that out. So our next step, don't know what that was. Try that again. Looks like this. Anytime we see parentheses, the parentheses should scream at us, do something here first. Is there anything we can do inside that parentheses? Well, we're not solving yet. We're still combining and simplifying. We can't combine 3x minus 7. They have different names. We cannot combine them. So then the next question we have to ask, is there anything we can do to the parentheses? And there is. Times 5. Now, some of you probably called this distributing if you took algebra before. All it really is, 3x minus 7 times 5 is a long multiplication, just like any other multiplication. 5 times negative 7 is negative 35. Again, that minus goes with the 7 that comes after it. 5 times 3x is 15x. But because we don't like writing it out and taking the extra space to multiply it out the long way, we use that process called distributing. It's just a shortcut. 5 times 3x, 15x, and 5 times negative 7, negative 35. So we get the same thing we did over here. It just takes a little less space and a little less time. Now it's in that form that we know how to solve again. What are we going to do? Add 35. 15x equals 60, and then divide by 15. X equals 4. And again, you could go back and replace x with 4 and make sure it comes out. I'll leave that up to you guys at this point. So now these can get a little tougher. I'm just making sure I don't screw it up is all. Other than Friday, I could probably do that in my head and keep track of it, but there you go. This one looks really ugly. I understand that. But first of all, before we start to solve it, we have to simplify and combine anything that we can on either side. So let's start on the left side over here. And we can combine, first of all, we see the parentheses, order of operations as we go left to right. So this is our first one here. Anything we can do in the parentheses? No. So we do have to do distributing. So you're right. 3 times 5x is 15x, and 3 times 1 is 3. So make sure it's a plus 3 because it is positive. Now the next parentheses we have to be very careful with. Nothing to do inside there. It's being multiplied by not 2, but -2. That minus in front of it goes with the 2. So -2 times 4x. -8x. There we go. And -2 times -3? +6. Now we do still have that -5 on the end there. Yeah, negative times a negative makes a positive. Now there's still things we can combine here. We have 15x and -8x makes, careful, +7x. +15 and -8 stays on the positive side. We've got 3 and 6 makes 9, and then 9 and -5. 9 minus 5 would be 4, right? So the left side is reduced to 7x plus 4. Do you want me to go back through some of that? Okay. Well, you've got, the 15 and the -8 makes 7. You can do either 15 minus 8x, or you can do 15x plus a -8x. Either one is fine. They mean the same thing. Yep. And then, of course, you've got 3, 6, and -5. So the 3 and the 6 combine to make 9. And then combine the -5 gets you back to 4. You can subtract 5. That works too. Adding a -5 and subtracting 5 are the same thing. Okay, on the right side over here now, we have the parentheses. We're just going to go ahead and distribute that 4. 4 times 2x, 8x, and 4 times -3, -12. Next parentheses, 3 times x. Now I'm going to put in a plus there because it is positive. So plus 3x. 3 times -2, -6. And then we do still have the plus 2 on the end. So we do have the 8x and 3x. They're both positive, so they make 11x. Now we've got -12, -6, and +2. So we'll do them 2 at a time. -12 and -6 make -18 plus the 2, -16. So we have 7x plus 4 equals 11x minus 16. Now we still have one issue before we can solve here, and that's that the variable still appears on both sides. We can only solve once we're down to the variable appearing once. So we're going to have to get rid of one of these. Which one do we want to get rid of? The 7 is the smaller one, so we'll subtract 7x. So 4 equals 4x minus 16. Now, if you wanted to switch that around to 4x minus 16 equals 4, you can do that if that's more comfortable for you. We're going to leave it like this for now. Where do I start here? Add 16. So 20 equals 4x. And then divide by 4. So 5 equals x, or x equals 5. Where did I lose you at? Oh, gotcha. I won't make you do anything quite that ugly. Yep. You will have some that they're like one side of that with decimals, and that's what we're going to look at next. So.
So like here when the -2 is in the middle.
Yep.
Just bring it
Yep. But you have to be very careful because, yeah, it's -8 because this is a +4. But now that -3 becomes a plus because the negative times the negative makes a positive. You have to make sure you carry that with. Yes. To make sure you have that symbol in there. Yep. And especially when it's positive like this, just bring the plus down so you got that plus there. Definitely. Okay. The reason we need to be able to solve equations kind of ugly like this is the next thing we're going to talk about is mixture problems. We're going to talk about in mixtures, what we're dealing with is combining two or more substances. We're going to stay simple here, so we're only going to be talking about combining two substances. And we're going to talk mostly about solutions. A solution has two ingredients in it, usually, and there could be more, but we're going to stick to simple binary solutions are called, two-ingredient solutions. Think of salt water is a solution. And in a solution, there are two ingredients. The solvent, which in the salt water would be the water itself. And then there is the solute, which would be the, in this case, the specks of salt that go in there. The solute disappears into the solvent to make a solution. If you ever look at salt water, you cannot see the salt in there. It disappears into the water. So that the salt is the solute because it disappears. The solvent is the thing that makes it disappear. It dissolves it is what it's called. But when we look at the concentration of a solution, concentration is given as a percent. A 30% solution is going to be written as a 0.3 or 0.30 concentration. Or a percent written as a decimal. The amount of the solute in the solution. The reason the amount of solute is important, by the way, is the solute is usually our active ingredient. Whether it's the medication, whether it's some sort of antiseptic, salt or sugar, it's the active ingredient. The solvent usually is water or sterile water. It's what we refer to as a vehicle. It carries that active ingredient into the patient. So the amount of the active ingredient, or the amount of the solute, is generally very important for us. That amount is equal to the concentration times the total volume. So if we have 200 milliliters of 12% hydrogen peroxide solution. Hydrogen peroxide solution is hydrogen peroxide is the solute dissolved into water. So the amount of hydrogen peroxide is equal to our concentration. What's our concentration here? 12%. So we're going to write that as 0.12 times, what's our volume? 200 milliliters is our total solution. We multiply that out, 0.12 times 200 is 24 milliliters. So there's 24 milliliters of hydrogen peroxide in that solution. Well, because it's concentration times total volume. So the concentration is the percent as a decimal. So that's the 0.12. And then I just put this in parentheses. Instead of putting the multiplication symbol there, I put it in parentheses because often we're going to have an expression for that. So it might be 200 minus x or x plus 30 or something like that. So I just get used to putting in parentheses. Okay, and that's what we're building up to. Yeah, the word problems take a while to get used to. Hang in there. Find the concentration when 36 milliliters of salt is dissolved into 200 milliliters of total solution. So first thing we have to do is identify what is the solute here. Perfect. The 36 milliliters of salt. So that is our amount of the solute. Find the concentration. We're asked to find the concentration. So we're going to put X there. That's our concentration. Times, what is our total volume? 200 milliliters. Now, some of you might be more familiar. I'm going to ignore the milliliters for just a minute. Since all of our units are the same, I can ignore them. Some of you might be more comfortable viewing this as 36 equals, instead of X times 200, viewing it as 200X. Either way, to solve it, we're going to divide by 200. So this is 0.18 equals X. So the concentration is 0.18 or 18%. If 200 milliliters of 15% solution is combined with 300 milliliters of 25% solution, find the final concentration. This just jumped up a couple levels of difficulty. We're now dealing with two separate solutions and mixing them together. Well, when we're mixing, we deal with having to combine the amount of the solute in solution A with the amount, I'm going to abbreviate just AMT, of the solute in solution B. That has to combine to equal the total amount of our solute. I didn't tell you what the solute, what the active ingredient was in these solutions, but it really doesn't matter. We're just looking for a concentration. So solution A is the 200 milliliters and 15%. Solution B is 300 milliliters at 25%. Now, it looks like we don't know anything about solution, the total solution, but we do know one thing. If I combine 200 milliliters with 300 milliliters, I'm going to get 500 milliliters. X is that concentration. That's what I'm looking for. So what we have here, the amount of solute in solution A, 15% is going to be written as 0.15 times 200 milliliters. The amount of solute in solution B, its concentration is 0.25 times 300 milliliters. Solution, the final solution, we don't know our concentration. We're calling that X times the 500 milliliters. So now it's time to solve this. 0.15 times 200 is 30. 0.25 times 300 is 75. And of course, X times 500, we'll just write it as 500X. We would now combine the 30 and 75 to make 105. Equals 500X. Then what? We're going to divide by 500. What does that give us? 0.21. So that is 21%. So that final solution is 21% concentration. Okay, as long as it works. Now, this equation wasn't hard to solve. It gets more complicated when we're missing the amounts of one of the ingredients. We don't generally just randomly mix two solutions together and see what we end up with. Generally, we have a target in mind. For example, we might have 32% solution and 48% solution. We might need 44% solution. Let's say we're going to ask how much 48% solution should be mixed with 120 milliliters of 32% solution in order to create 44% solution. So this would be our problem as it's originally written. And I would pick out of that problem, okay, how much 48 mixed with 32? We have 48 and 32% solution. We want to create 44%. That's what we need is 44%. So now we need to map this out. We're going to combine our 32% with 44%, hopefully to create, or not 44%, with 48%, sorry. Hopefully to create the 44%. What amounts do we know? We know that 120 milliliters goes with which one? 32. That's the only volume we're given. We're asked how much of the 48%. So I'm going to let X be the amount of the 48%. How much of the 44% do we have then? Well, up above, when we had 200 milliliters and 300 milliliters, we added them to get 500 milliliters. We've got 120 plus X. is the amount of the 44%. So then our equation becomes 32% is going to be 0.32 times 120 plus the 48% becomes 0.48 times x. That's going to equal our 44%, 0.44 times, that's 120 plus x in that parentheses. And now we've got to solve for x. It's not as bad as it looks, I swear. 0.32 times 120 is going to be, was that 38.4? Perfect. Plus 0.48 times x is 0.48x. On the other side here, we're going to distribute 0.44 times 120, so that's 52.8. And 0.44 times x is plus 0.44x. Now we have an x on each side. We have to get rid of one. I'm going to get rid of the 0.44. I have to take the 0.44x away from the 0.48x. 0.04x. That's a positive. We still have the 38.4 up here. And this is 52.8. And now we can solve that equation for x by subtracting 38.4. 0.04x equals, was that 14.4? And then we'll divide by the 0.04. X equals 360, I believe. What do you think? We're going to do a lot more of these next week. This is just to get us introduced to them, give you a week to think about them before we dive into them real deep. For homework problems to try, page 49 through 50, 1 through 43, the odds. That's just solving equations. To dive in to get a start on these mixture problems, again, please don't get frustrated if you struggle with these. We're going to talk about these way more next week. On page 53 and 54, 1 through 15 are the mixture problems. That says odd there, yeah. I need to work on my handwriting. But the mixture problems, if you want to take a look at those and try some, like I said, if they're not working out, don't be afraid. We are going to go over a lot more of that next week. Okay, it's time for us to get out of here. You guys have a great weekend.